Okay, everybody able to see the screen?
Yes, sir.
Yes, sir.
Okay, so last time we seen the coupling of protons on nucleus what P31. Okay, before that we seen the coupling of proton with deuterium as well as F19. So here we already seen F19, deuterium, phosphorus 31, and right silicon 29. So when proton attach to this nucleus, okay, then what happen in that
Hey.
case? So coupling constant is there,
Huh?
quadrupole interaction is there. Okay,
Shirit घुने की पार्टी तो
so
लेक्चर चालू नाही
everyone
काढत
sees that coupling of
काढलं की
proton
सिम कार्ड जात आहे
to
बाहेर
silicon 29.
मोबाईल घेऊन ये पप्पाचा शेअरिट करतो दुपारी
So
आला म्हणून
who talk? Please mute
मग मी
yourself.
दुपारी नंतर कॉपी करून घे.
Hello, who's talking? Please mute yourself because you disturb the class. Okay, so in case of coupling of protons to silicon 29, what happened here? You have to see the NMR active 29 silicon isotope has a natural abundance and it is about 4.70%. Okay, but the natural abundance of silicon 28 is what 92.28%, and its spin number is 1 half. Okay, the value of J for what silicon 29, those are attached to the hydrocarbon, that is proton, is about 6 hertz. The low intensity doublet caused by the silicon 29 CS3 coupling can often seen starting, that is plus minus 3 hertz, an amplified peak of TMS. The low intensity of C13H proton, that is satellite doublet, can also seen at plus minus 59 hertz. 29 silicon spectra can be obtained at the appropriate frequency and magnetic field. Okay, so that part we seen that where we have to see the two silicon isotopes 28 and 29, but 29 is NMR active, and if the proton that attached to the NMR active silicon, then what happens? Its coupling constant value is 6 hertz. Okay, so that things you keep in mind that. And while silicon 28, which having its abundance is 92.28%, so it is a large abundance, but it is NMR inactive. Okay, so most important, I think you will see the C13 NMR spectroscopy. Okay, in that, Chavan sir started it. Yes or no? Hello.
No, sir. No,
No.
sir.
Okay.
No, sir.
So you will see in case of C13 isotope, where the C13 isotopes is comparatively very low, that is 1.1 only, and if you compare to the C12, then it is 99%. Okay, so only 1.1% isotopes of C13s are there, and its spin number of 1 half. So proton directly attached to the C13 are split into doublet with a large coupling constant. Okay, so when proton, that is, you know that the proton, that is hydrogen, is attached to the carbon, that is C13, then what happens? It generally gives the doublet. That doublet having a special, why? Because it having large coupling constant, and its coupling constant value is what you see, 115 to 270 hertz. So in previous cases, you've seen that the 6 hertz is there, then 50 hertz is there, 25 hertz is there. But in case of C13, what happened? There is a coupling constant value. It is about 115 to 270 hertz for C13H coupling. Okay, the CH3CH2 group, okay, group for example is predominantly where CH3, this carbon having C12 isotope, this carbon also having C12 isotope, but contains a small amount of C13. Okay, means any compound of hydrocarbon. Okay, all of you know that ethanol, methanol, then straight chain compound, that is methane, ethane, butane, propane. So every hydrocarbon compound which having maximum number of isotope of what, carbon 12, but there is a small amount of what, C13 isotope. Suppose one of the carbon from this group CH3 CH2, CH3 having isotope C3, that is small amount, it containing both C12 as well as C13, but C13 is what, very small amount, and it couples with what, C12H2. And another possibility, here is what, C12, and here is what, C13. So vice versa is there, because every hydrocarbon compound containing small amount of C13. Thus the C13 CH3 protons are split into doublet by C13. Okay, so only C13 protons from this group CH3 CH2 group is splits into what, doublet by, due to why, C13 is there, and its J value is near about 120 hertz. Okay, and each peak of the doublet is split into triplet by the CH2 protons, because you know that this gives triplet and this CH2 gives what, quartet. Okay, so here each peak of the doublet splits into triplet by CH2 protons. Its J value is about what, near 7 hertz as shown below. So these C13 satellite peak are small because of the small number of molecules containing the C13 in the CH. Okay, so all of you understand that every hydrocarbon containing C12 and C13 isotope, but the amount of C13 isotope is very less. Okay, that's why every hydrocarbon, that carbon attached to the proton shows the peak in the NMR spectroscopy. Why? Because every hydrocarbon containing small amount of CH3 and can usually be seen disposed on both sides of a large CH3 peaks. Okay, so if you see here, CH3 C13 is there, then what happened? Here is the large value of what, near about 120 hertz. Okay, and you see here, here is the J13 coupling is there for CH3 CH2, it is about 7 hertz, while for this CH3 13 CH2, so both is what, about 7 hertz coupling constant value. Okay, so here depending upon the which type of hydrocarbon near to the carbon atom, that splits into their value. But if you see the nucleus of other, then what happen, what you see in case of C13, in C13 the coupling constant value is large. Okay, and it is about 115 to 270 hertz. Okay, so all of you understand this one?
Yes, sir.
Okay, so another thing we want to see in case of this, that is alternating axis of symmetry, it turns about, so this is not part. So these are the parts
Hello.
of proton, those are attached to what, different nucleus, and that nucleus is what, F19 deuterium, phosphorus 31, silicon 29, and C13. All of you understand it? Hello?
Yes, sir.
Okay. So almost all part we seen in the NMR spectroscopy. That is coupling constant, geminal means what, visinal means what, long range coupling means what, multiplicity rule means what, Pascal triangle, then chemical shift, as well as anisotropic effect, shielding de-shielding pattern, and the spin state, how the spin state of nucleus is there, then precessional frequency. Okay, so many more terms we see in case of what, this NMR spectroscopy. So next part of this we want to see. But before that, I I have already given to you assignment. Yes or no?
Yes, sir.
Okay. And I hope so. All of you completed it. Completed or not?
Completed.
Everyone.
Yes, sir.
Okay.
Yes, sir.
So today I will send you email. Okay. And on that email, you have to scan your notes and send me on that email. Okay. So before 2 o'clock at afternoon, you submit your assignments. Anyone have any problem? Among 30 students are present. Anyone have any problem?
No, sir.
Okay. So hopefully today I will get all the notes regarding the NMR spectroscopy. So what happened up to this point, we should complete all the important points related to the NMR spectroscopy. But not only concept understood by theory, it is very important to see the examples. Okay. And along with example, the different terminology which is used in the NMR spectroscopy, that is the most important. So whatever part we seen from this lecture, it is very important for the solving of the examples. Suppose if you take the example for a coupling constant is a benzene ring, or you attach OH group to the benzene group, then it is phenol. So only one concept is there, coupling constant or chemical shift. But when you see in the case of benzene ring, that chemical shift or another thing is what, coupling constant is different for aromatic ring and for phenol. No doubt, phenol having benzene ring, but there is one addition of what, hydroxy group. So both concept, same theory, but we see the differences according to the functional group. And that's why this NMR spectroscopy is the very effective and important tool for understanding the structure. By the NMR spectrum, you should know that what kind of structure of your molecule. Okay, all of you understand it? Yes, no?
Yes, sir.
Yes, sir.
Okay, so next part, and it is very important. It is related to the multiplicity. Okay, and multiplicity, all of you know that. Multiplicity means what? Yes. What is meant by multiplicity?
Splitting of a signal.
A group of hydrogen.
Group of hydrogen. Multiplicity is the nothing but the Pascal triangle. Okay. Yes, you seen that? Are you able to see in the screen? Yes, no,
No, sir.
no. Now, now you see?
Yes, sir.
Okay. So this part we seen previously. That is singlet means what? N, that is multiplicity, relative intensity, and spin and coupling pattern. If you see here, if n is equal to 1, the coupling constant is there, only 1j is there. If n is equal to 2, 2j is there. If n is equal to 3, 3j is there. But you see the spin states, okay, that is aligned and unaligned. So these are the Pascal triangle, and all of you very well to know this Pascal triangle, how it is calculated. And I think everyone itself calculate this Pascal triangle. Yes or no? Yes or no?
Yes, sir.
Okay.
Yes, sir.
So previously we discussed that here is one, then doublet is what? One, one. So triplet is what? It's a addition at middle. One plus one, two, one, one. So at everywhere you add one, 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 one. Okay. This is a triplet. Then for quartet, two plus one, that is three. 2 plus 1, that is 3, 1, 1. It means what? Quartet. What about quintet? That is the four signals are there. Okay. So 3 plus 3, 6, 3 plus 1, 4, 3 plus 1, 4, 1, 1. Then for sextet, 4 plus 6, 10, 4, 6 plus 4, 10, 4 plus 1, 5, 4 plus 1, 5, 1, 1. For septet, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6, 1. Here 10 plus 5, 15, 5 plus 1, 6, and 1. In case of octet, that is 20 plus 15, 35, 20 plus 15, 35, 15 plus 6, 21, 6 plus 1, 7, and 1 is here. And in case of nonet. So all of you very familiar with this multiplicity rule. Yes or no?
Yes, sir.
Okay, and all of you know about the coupling constant, that is the J value. Okay, so on the basis of that, today the first and important part we will see, because all of you know about the chemical shift, then multiplicity rule, coupling constant, J value, integration, shielding, de-shielding, anisotropy effect, what kinds of proton of attached to the oxygen heteroatom, oxygen, chlorine, bromine, fluorine, then deuterium, then if ether is there, enol is there. So all kind of possibility of proton you have to study. Yes or no?
Yes, sir.
Okay. So that whole base is required for the next and advanced part we want to see in the NMR spectroscopy. So from this lecture, next I think 4 to 5 lectures is important for the aspects of NMR spectroscopy for MSc second year. Okay, because in BSc third year, MSc first year, and also in MSc second year, you see the NMR spectroscopy. But whatever we see previously, that all are the basic part of that NMR spectroscopy, and everybody very familiar with that part. Why? Why I'm say familiar? Because it is too much important for your next studies or higher studies. Then what is meant by first order spin system? Okay, so spin, all of you know that what is meant by spin. So what is meant by first order spin system? The spin system consists of multiplets, no doubt. Multiplets, all of you know that. That is this one, multiplicity, singlet, doublet, triplet, quartet, quintet, sextet, septet, octet, nonet. So this is called as a multiplicity. Okay, this is called as a relative intensity, and this is called as a spin. If n is equal to 1, then what type of spin? If n is equal to 2, then what type of the spin? So what is possibility here? If n is equal to 1, then one is aligned, another one is unaligned. Okay, so you have to see the direction. If two spin state is there, what is possibility there? The two spin state, both are anti-parallel, both are parallel in the same direction. And another case is what? In the another direction, that is opposed to each other. Okay, that's why you see here in coupling pattern, those are opposite to each other, these are at middle. Okay, but those are in the same direction, that is upward and downward, then it gives the coupling constant. So whatever anti-parallel or parallel, it minimizes because of the two spin state, parallel as well as anti-parallel. That's why it becomes zero. Okay, both spin states having opposite direction, then it having the zero. You see here. Okay, and both are parallel in the same direction, that is upward direction or downward direction, then its coupling constant is here. And that relate to where? That related to opposite speed to each other. All of you understand this one?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So those are opposite to each other, that minimizes and it is at a zero. Okay, but those are in opposite direction, both spin in parallel or in downward or in upward, then it having the spin, and that related to the opposite spin. If you see n is equal to 3, so what is possibility? The 3 is total 3 spins in downward direction, total spin state in upward direction. Okay. Another thing is what? 1 is downward, 2 is upward, 1 downward, upward, second downward, third upward, 2 upward, 1 downward. So here not, because in case of n is equal to 2, you seen that one is upward and one is downward. That's why it minimizes. But in this case, if n is equal to 3, then what happen? There are no that spin state. That is 2 is upward, 1 is downward. Here 2 is upward, 1 is downward. Here 2 is upward, 1 is downward. In this case, 2 is downward, 1 is upward. 2 is downward, 2 is downward, 1 is upward. So that's why this having this coupling constant, and there is no any spin state which having the equivalent. Equivalent means what? One is opposite and one is downward, like this. No such type of spin state is observed in case of n is equal to 3, and that's why this line is blank here. But in case of this, you have to see here is the two line, and that at coupling constant value. Okay, and that's why n is equal to 3. Then the coupling between this and this, the coupling between this and this. So the coupling between this and this is J1 value, then this and this, that is this. This is the J value, and another one is the J value. So n is equal to 3, having 3 coupling constants. Okay, all of you understand this one, coupling pattern, how the coupling is occur? Yes, no?
Yes, sir.
Yes, sir.
Okay, so whenever you see in problem J values, number of J value is there, that also gives the spin state and it shows the multiplicity. Okay, so in NMR problem, number of time J value given to you, and it is very important to know that this aspect to you for the solving the problem. Okay, so on the basis of this multiplicity, today we will see the first order spin system. So what is mean by first order spin system? Okay, so a spin system consists of multiplets, no doubt, that couple to one another but do not couple outside the spin system. Okay, so spin system that couple to one another, it is okay, but that not couple with outside the spin system. Means what? Suppose CH3, CH2 and CH3 is there. Okay, so this CH3 coupled to CH2. Okay, so this coupling system is there. Okay, that is multiplets couple to one another, but do not couple to this CH3. CH3, CH2, CH3. CH3 couple with what? CH2. Not couple to the outside the spin system, that is CH3 coupling. Here is only what? CH3 CH2 coupling. This CH3 also coupled with only CH2. It not coupled with the CH3. Okay, and that's why it is do not couple outside the spin system. It is not necessary for every multiplet within the spin system to be coupled to every other multiplets. Okay, so it is not necessary. Those are near, that only we want to couple. Okay, for example, during the when you attend the class, you sitting on bench. Okay, so two students sitting on the bench. जर का तुम्ही दोघे जण जर बेंचवरती बसला असाल तर तुमच्या लेफ्ट आणि राईट साईडला जे आहे, फॉर एक्झाम्पल तुम्ही एका बेंचवरती बसलेला आहात आणि तुमच्या शेजारी तुमचा मित्र आहे आणि त्याच्या शेजारी कोण आहे, याचा इफेक्ट तुमच्यावरती होणार आहे का? येस नो? येस नो? हॅलो,
येस सर.
होणार आहे का इफेक्ट त्याचा?
शेजारच्या जवळचा त्याचा.
आपण एका बेंचवरती, ओके, जर का आपण इथं बसलेलो आहे, आपला मित्र आपल्या शेजारी आहे आणि त्याच्या पलीकडे जर कोण एखादा तुमचा मित्र असेल, तो जो डिस्टर्ब करणारा असणारा, तो जास्त इफेक्ट कोणावर होईल? तुमच्या मित्रावरती होईल का तुमच्यावरती होईल?
मित्रावरती.
मित्रावरती होणार, बरोबर. म्हणजे इट इज नॉट नेसेसरी यू हॅव टू अटेन्शन देअर. त्याच्याकडे लक्ष द्यावं असं काही नेसेसरी आहे का?
नाही.
पण तुमच्या शेजारचा जो मित्र आहे, जो तुमच्या बरोबर बसलेला आहे, तो जर काय डिस्टर्बन्स करत असेल तर तुम्हाला इफेक्ट होणार का नाही?
येस.
या हा इथं मल्टीप्लेट मध्ये हे इम्पॉर्टंट आहे. तुमच्या शेजारी कोण आहे, त्याच्या पलीकडे कोण आहे याच्याशी आपलं देणं घेणं नाहीये, किंवा सगळ्यांनीच म्हणजे कपल व्हावं असं काय नाहीये. तर तुमच्या शेजारी कोण आहे, इट इज नेसेसरी. दॅट्स वाय स्पिन सिस्टीम हिअर, it is not necessary to every multiplet within the spin system to be coupled to every other multiplet. Okay, it is not necessary. A spin system is insulated from other spin system by heteroatoms. Okay, so you see here, a spin system is insulated. Insulation, all of you know that. What is the meaning of insulation? So spin system is insulated from other spin system, okay, by what? Heteroatoms and quaternary carbon, that atoms without attached the hydrogen atoms, that is quaternary carbon. Okay, so the spin system is insulated from other spin system by what? Heteroatoms and by quaternary carbon. So other spin system is influenced or insulated by what? Heteroatoms or quaternary carbon. For example, suppose CH3 is here, CH2 is here, and then OH is there. Means in case of ethanol, CH3 CH2 OH. So CH3 couple with CH2. Okay, this coupling constant is there, multiplicity is there, and all of you know that CH3 gives triplet and CH2 gives quartet. Okay, but when you go for the oxygen, CH2 attached to what? Oxygen. Then what happened? The hydrogen attached to oxygen gives triplet. Yes or no?
No.
Why? Because there is a oxygen atom. Okay,
Yes.
and that oxygen atom is not coupling with CH2. Means what? This spin system is insulated from other spin system by heteroatoms or quaternary carbon. All of you understand this one?
येस सर.
म्हणजे काय होणार आहे की CH3 आणि CH2 आणि OH हे जर सिस्टीम असेल तर याच्यामध्ये काय असणार आहे, CH2 जो आहे तो OH बरोबर कपल होणार नाहीये. का होणार नाहीये? कारण की तिथं हेटेरोएटम प्रेझेंट आहे. किंवा त्या ठिकाणी जर असा कार्बन ॲटम असेल की ज्याला एक हे हायड्रोजन अटॅच नाही. फॉर एक्झाम्पल CH3 CH2C, CH3 CH3 CH3. ओके, म्हणजे हा कार्बन ॲटम कोणत्याही हायड्रोजन ॲटमला अटॅच आहे का? नाही. तिथं काय CH3 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 आणि हा कार्बन ॲटम CH2 ला अटॅच आहे. म्हणजे हा फक्त कार्बनच ॲटम आहे. इथं कोणता हायड्रोजन ऍटम आहे का?
No.
नाहीये. तर त्याला काय म्हणायचं? क्वाटर्नरी कार्बन. म्हणजे एखादी सिस्टीम कशी इन्सुलेटेड होती की अदर spin system by heteroatoms or by quaternary carbon. So these two important points you keep in mind that. So spin system is insulated from other spin system by heteroatoms and by quaternary carbon. Then next you see that the multiplates are coupled as a simple first order. So you see here what is meant by first order. Okay, the multiplates are coupled as simple first order, complex first order, or higher order. So that three order you always concentrate there. Multiplates are coupled and they form what? Simple first order or complex first order or higher order. So three type of coupling of multiplates are there. What is that? Multiplates are coupled as first one simple first order, second one complex first order, and third one higher order. Okay, all of you understand this?
Yes, sir.
Hello, hello.
Yes, sir.
Okay, so multiplates are coupled as a simple first order, complex first order, or higher order. In a spin state, in a spin system, there may be long range coupling. So all of you know what is meant by long range coupling through the insulating atom. Okay, in a system there may be. So here is the possibility. First, what we say, that is insulation. We say due to why? Because of the heteroatom or quaternary carbon. But there is a maybe possibility, that is long range coupling through insulating atom. But this usually involves small coupling constant. Resultant, the appearance of peak is broadening. Appearance of peak is what? Broadening. म्हणजे काय की सपोज इन्सुलेशन काय आहे इथं? हेटेरोएटम आणि काय आहे? क्वाटर्नरी कार्बन आहे. आपण काय सांगतोय की CH3CH2OH. तर CH3CH2 चं जे कपलिंग आहे ते CH3 चं OH बरोबर होणार नाही, कारण हायड्रोजन ऑक्सिजन ऍटम तिथे आहे. ओके, पण काय होतं जेव्हा आपण वर्गामध्ये बसतो तेव्हा आपला मित्र आपल्या शेजारी असतो, त्याच्या पलीकडचा जो मित्र असतो त्याला कधी कधी असं वाटतं की नाही आपल्याला याच्याशी बोलायचं आहे. म्हणजे सपोज योगेश बसलेला आहे, त्याच्यानंतर कोण आहे? कल्पेश, आणि त्याच्यानंतर त्यांचा एखादा मित्र आहे, म्हणजे ABC. तर AB हे कसे आहेत? बरोबर आहेत. ओके, आणि C कसं आहे? योगेश पासून लांब आहे, A पासून लांब आहे. मध्ये कोण आहे? B आहे. पण C कधी कधी एवढी ऍक्टिव्हिटी करतो की त्याच्यामुळे हे काय होतो? डिस्टर्ब होतो कधी कधी. ओके, सो डिपेंड अपॉन द नेचर ऑफ टीचर इन फ्रंट ऑफ यू. जर टीचर जर काय बोलणार नसते तर सी तसा वागणार है ना. तर त्यामुळे काय होणार आहे? तिथं लॉंग रेंज कपलिंग येणार आहे. सो इन सिस्टीम देयर मे बी लॉंग रेंज कपलिंग through the insulating atom, but this usually involves very small coupling constant. And due to small coupling constant, the peak appearance is broad. The peak appearance is a broad. You see here. Here is the chlorine, CH2, CH2O, CH2, CH2Cl. Okay. So here is the heteroatom. Here is the heteroatom. The coupling occur in this CH2, CH2, it's okay. But there may be, even though this presence of this oxygen, this CH2 couple with this CH2 or this CH2. Okay, but such type of cases occur, but it not gives the significant value. It gives what? Only small coupling constant. And what is the result of small coupling constant? Whatever peak is observed, you see here the peak is observed, that peaks are what? Broad.
Broad.
That peaks are what? Broad. All of you understand this one?
Yes, sir.
So the name of this compound is chloroethyl ether. Chloroethyl ether, where you have to see the broadening of peak. And this broadening of peak is due to why? Because of the spin is coupled through the heteroatom or through the insulating atom with another spin system, and this result in a small coupling constant, and that small coupling constant gives the peak broadening. So whenever you see the spectrum, NMR spectrum, at that time this peak broadening is occur, then you should know that why this peak broadening is occur, because of the small coupling constant. And small coupling constant is due to why? Because of long range coupling is there, and while long range coupling is there, there may be possibility to this CH2 is coupled with another spin system. So one spin system interact with another spin system, even though there is an insulating atom. Okay, all of you understand?
Yes, sir.
Okay, so you see here in the 600 megahertz spectrum in figure 3.3 consists of simple first order spin system. So this is called as a simple first order spin system, where as does the 300 megahertz spectrum, but with mirror distortions. The 600 megahertz 60 megahertz spectrum consists of higher order spin state. Okay, so here in this case A is what? This A is 60 megahertz, B is what? 300 megahertz, while C is what? 600 megahertz. So if you see, we have to increase the megahertz, that is the intensity frequency of this instrument, then you will observe that the 600 megahertz having the sharp peak. You see the sharp peak is here. If the low frequency instrument is there, then what happens? The peak is observed. No, here is triplet, here is triplet. But you see here we see the doublet also in triplet. Okay. But when you see the 60 megahertz, then what happens? Very low intensity is there. No doubt here is the spectrum 1, 2, 3, 1, 2, 3. So this peak appear like this one. Okay. And from that we cannot understand anything. So the spectrum consists of A. So this spectrum is called as a simple first order spin system. What called it? Simple first order system. The spectrum for the 300 is the minor distortion, while the system with 60 megahertz spectrum that consists of higher order spin system. Okay, so this is called as a higher order spin system. Means what? If magnetic frequency is less, then long range coupling occurs. If means what? जर का एखादे कडक टीचर असतील वर्गामध्ये, तर तुम्ही सगळे कसे असता? दंगा करता का कोण? येस? नाही. आणि एखादे तुम्हाला समजून घेणारे असतील, काय न बोलणारे असतील, तर लगेच तुमचं काय हालचाली डिस्कशन सुरू होतं. बरोबर? बरोबर?
येस.
तसं जर का मॅग्नेटिक तुमची इंटेन्सिटी जर प्रॉपर असेल, म्हणजे हायर रिझोल्युशन असतील, तर तुम्हाला पीक कसे भेटणार आहेत? शार्प भेटणार आहेत. कारण ह्या मॉलिक्युलना एवढी मॅग्नेटिक सिस्टीम अप्लाय होणार आहे की त्यांना त्यांचं वर्क जे आहे ते प्रॉपर केल्याशिवाय पर्यायच राहणार नाही. पण जर का मॅग्नेटिक फ्रिक्वेन्सी कमी झाली तर ते काय करणार आहे? देयर मे बी पॉसिबिलिटी हा CH2 काय करेल? कपलिंग विथ दिस CH2 लॉंग रेंज कपलिंग करेल. ओके, मीन्स इट डिपेंड्स अपॉन द फ्रिक्वेन्सी ऑफ इंस्ट्रूमेंट. सो सिंपल order spectrum, then complex order spectrum, and this is higher order spectrum.
Higher order spectrum.
Okay, so it depends upon what? It depends upon the frequency of instrument. Okay, all of you understand this one?
Yes, sir.
Okay, so a spin system may consist of one or more higher order multiplets, in which case it is difficult to determine all the delta value, coupling constant, and multiplies by the inspection. Okay, so figure 3.50 offers an example event at. Okay, we will see later on this one, but एकच लक्षात ठेवा की 1600 मेगाहर्ट्ज म्हणजे लो मॅग्नेटिक फ्रिक्वेन्सीला जर एखादा स्पेक्ट्रमचं इंटरप्रिटेशन केलं तर त्याच्यामध्ये आपल्याला डेल्टा व्हॅल्यू, कपलिंग कॉन्स्टंट आणि मल्टिप्लेट हे व्यवस्थित डिटरमाइन करू शकत नाही. फॉर एक्झाम्पल CH3 CH2OH. All of you know that CH3 gives what? Doublet. CH2 gives quartet while OH gives singlet. Okay. जर का हा कंपाऊंड असेल आणि जर त्याचे हे काय असतील पिक्स असतील तर तुम्ही 600 मेगाहर्ट्ज इन्स्ट्रुमेंट वापरलं तर तुम्हाला काय दिसणार आहे? प्रॉपर ट्रिपलेट, प्रॉपर डबलेट, प्रॉपर सिंगलेट. याला कोणत्या टाईपचा स्पेक्ट्रम म्हणायचं अंकिता?
सिंपल
फर्स्ट ऑर्डर
स्पेक्ट्रम. जर का तुम्ही सेम कंपाऊंडचा जो काय NMR आहे तो 300 मेगाहर्ट्ज ला घेतला तर याला काय म्हणायचं?
कॉम्प्लेक्स फर्स्ट
ऑर्डर स्पेक्ट्रम.
फर्स्ट ऑर्डर.
ओके. आणि हा जर का स्पेक्ट्रम तुम्ही 60 मेगाहर्ट्ज ला घेतला तर तुम्हाला प्रॉपर सिग्नल दिसणार आहेत का?
नाही.
इथं काय दिसणार आहे तुम्हाला? ब्रॉडनिंग ऑफ द पीक दिसणार आहे. काय दिसणार आहे?
ब्रॉडनिंग ऑफ पीक.
जीवन का आपल्याला ब्रॉडनिंग ऑफ पीक दिसणार आहे? व्हॉट इज द रिझन? जीवन शिंदे.
Small coupling constant.
Yes, sir. Because of instrument frequency is less.
Yes, but why we observe due to less frequency broadening of peak is there.
Higher coupling is observed.
Higher, that is called as long range coupling.
Long range
and
coupling.
small coupling constant. So these important 2 points. Long range coupling, and due to that small coupling
constant.
the peak is broadened due to the low frequency. So this is called as a complex, simple and higher order spectrum. Okay. So it is notable that chemical shifts are usually reported to chemical places, but are these numbers always valid? That is question. Certainly they are for the almost perfect first order triplets at 60-100 megahertz in figure 3.33. At 60 megahertz, however, chemical shift of the overlapping multiplets cannot be measured accurately by inspection. Somewhere about 300 megahertz and 600 megahertz attempt to measure the chemical shift of similar compounds would only yield approximation but not values accurate to two chemical places, 2 decimal places. Okay, means what? Here in case of 600 megahertz we have to interpret that spectrum very accurately, but in case of 300 and 600 that much accurate decimal places will not assign. Okay, so here is the one example, that is aromatic ring that attached to the different protons. Here is the olefinic protons that attach to the aromatic ring. So here HAMX, so 3 type of protons are there along with aromatic protons. So we see the A and X, so these A and X proton couple with the M. So these both coupling with what? This M proton. But the A group does not couple with the X. That A does not couple with X because here is a M. The analysis is presented in section after the discussion of some relevant material. At this point, we note only that the spectrum consists of 2 triplets with slightly different coupling constant and a sextet with slightly broadened peak. Okay, so here 2 at this point. Okay, so this proton couple with this proton couple with this, but this HA not couple with HX. Okay, at this point only that the spectrum consists of 2 triplets with slightly different coupling constant. Okay, so here 2 triplets are there and that containing slightly coupling constant. But what happened? A sextet with slightly broadened peak. So sextet, if appear as a sextet and it is slightly broadened, then what happen? This HA is coupled with HX when it has the sextet, and it is what? Slightly broadened peak. So it is called as a long range coupling. Okay, all of you understand this? Hello?
Yes, sir.
Okay.
Yes, sir.
So you see here, all of the vinyl protons are weakly coupled with each other. So this vinyl proton, these are the vinyl proton, these are the vinyl. Vinyl means what? Olefinic. Okay. So that are weakly coupled with each other in 600 megahertz. As mentioned above, the letters close together in the alphabets are used to describe spin state that are not first order. For example, AB, A2B, ABC, A3B, B2, C2, etc. These spin systems are termed as higher order and cannot be interpreted by inspection. Means what? Here AXM system is there. Okay. So if you see this vinylic proton, here is what HM, and that's why vinyl protons are weakly coupled with each other, even though it having the higher frequency. Why? Because of the long range coupling. Okay, coupling constant is very small one, and that's why peak broaden is there. As mentioned above, the letters close together in the alphabets are used to describe spin state. Okay, so from this, this is the important point, and that we will see detail later on. So just you keep in mind that, as mentioned above, the letters close together in the alphabets means what? AB, ABC, ABCD, likewise. So the letters close together in alphabets are used to describe spin state that are not first order. Okay, so first order is not like that, because you know that first order very clear spectrum is there. Okay, with higher frequency. But AB system, A2B system, ABC system, A3, B2C2 system, etc. These spin states are termed as higher order and cannot be interpreted by inspection. Means what? Whatever system we want to see in further, that is AB, AB2, where definitely what? Broaden of peak is there. And why this broaden of peak is there? Because of low frequency instrument is there. And another thing is that in that molecule, there is a long range coupling is occur, and due to long range coupling there is a small coupling constant, and due to small coupling constant the peak broaden are takes place. So whatever system that is alphabetically closed systems, AB system, A2B system, ABC, so any system that are not interpreted by inspection, and that all systems are called as a higher order system. All of you understand?
Yes, sir.
Yes, sir.
ओके, म्हणजे आपल्याला एबी एबी ह्या ज्या सिस्टीम बघणार आहे ह्या आपण कशामध्ये बघणार आहे? हायर ऑर्डर मध्ये बघणार आहे.
Higher order.
हायर ऑर्डर मध्ये काय आहे की तिथं कोणती पॉसिबिलिटी आहे? लॉंग रेंज कपलिंगची पॉसिबिलिटी आहे. म्हणजेच काय आहे? कपलिंग कॉन्स्टंट तिथं कमी आहे आणि त्यामुळे पीक कसा आहे? ब्रॉड आहे.
Broad.
Okay, so beyond this systems are those containing magnetically non-equivalent proton, which are quite common and have unpleasant aspect. They cannot become first order system by increasing the magnetic field. These spin systems are discussed in section 3.12. Okay, so अशा ज्या काही सिस्टीम असणार आहेत त्याच्यामध्ये म्हणजे मॅग्नेटिकली नॉन इक्वलंट प्रोटॉन्स असणार आहेत. ठीक आहे, आणि इवन दो तुम्ही जर स्ट्रॉंग मॅग्नेटिक फील्ड त्याला अप्लाय केलं तरी सुद्धा त्यांचा फर्स्ट ऑर्डर सिस्टीम कशी असणार आहे? कशी असणार आहे? यस, हायर ऑर्डर असणार आहे. ते फर्स्ट ऑर्डर मध्ये येणार आहेत का?
नाही.
नाही येणार. ते कसे बसणार आहेत? हायर
ऑर्डर.
Okay, and there are collection of calculated spectrum that can be used to match complex first order splitting patterns. So you have to refer the Wiberg 1962 and Bowie 1988. Alternatively, these spin systems can be simulated on computer of a modern NMR spectrophotometer from, for example, see the NM are SIM, NMR SIM computer program available from Bruker BioSpin. So Bruker is the most advanced instrument of the NMR spectroscopy, Bruker BioSpin. Okay, and you have to see NMR SIM by a computer program for this type of the uh, system. Okay, all of you understand this one?
Yes, sir.
Okay, so next lecture we will see about the Popal notation. So whatever we see right now, AB, ABAX, ABC system. So that we will see, and it is related to what? First order, higher order, and complex order spectrum. All of you understand this concept,
Yes, sir.
and this is the most important concept. Okay, all of you keep in mind, and this is based on what? Your multiplates or spin state. Okay, so I will provide you the email just after completion of this lecture, and then you will send your notes. So every student after 2 o'clock, I have not seen that email. Before 2 o'clock, you send your notes, whatever we give assignment to you, and after that we will see the examples along with the theory. So 4 lecture is required for completion of your theory, and after that we will see actual examples by the spectrum or by the formula. Okay, all of you understand?
Yes, sir.
Yes.
Okay, so any question? So today we will stop here. Okay, so you keep in touch with your study, and another thing is that you actively participate online events. Those are organized by our institute, and stay at home and take care yourself. Have a nice day. So we have to leave the meeting. So Akshay Barge, Suresh Khandekar, Shweta Chive, please leave the meeting. Rutuja Pawar, Sanjay Lolge, please leave the meeting.